Hello everybody, and welcome back to another video on my channel. Today, we will be talking about another test that we can use to determine whether the series converges or diverges. And, as in the title, it's called the root test. So, let's explain it. Alright, so how does this work? Let's say we have an infinite series of some function f of n. Now, the idea is we take the limit as n approaches infinity of the nth root of f to the n. This is also the same thing as limit as n approaches infinity of f of n to the power of 1 by n. And there are again three conditions. The first condition is that if this is greater than 1. If greater than 1, then the series diverges. If it is equal to 1, the series is inconclusive. And finally, if it is less than 1, the series converges. Now, this is actually a very good way to see if another type of series converges. If you have any guesses, feel free to leave them in the comments and explain why. So, this series is the geometric series. Now, if you noticed, the geometric series takes the form of something or of some number to the n. So, n to the m. And if n is less than 1, it converges. And also, if it's equal to 1, series is inconclusive, but most of the time it will diverge. I'm pretty sure there are some exceptions, but feel free to say in the comments that if I'm wrong. Now, let me show you why the geometric series converges. Now, what we have is, since we have this over here, we can do the root test on it. So, limit as n approaches infinity of m to the n, and then taking root m or raising it to the power of 1 by n gives us limit as n approaches infinity of m, which is just m. And if m is less than 1, then it converges because the root test also says that it converges. So that's actually a proof for showing how the rules of the geometric series are there, as it's simply just an offshoot of the root test. Now, it's not just that you're going to be using it for geometric series. The biggest case that you're going to use this is, let's say n is equal to 1 to infinity, is you have some function of n taken to the power of some constant, k most of the time, times n. And this is essentially the form where you want to use the root test. Now, what it might also seem a little complicated as first, as the functions you might be dealing with something like 2n squared plus 3n to the 5th plus 7n cubed divided by 4n to the 5th plus 15n cubed plus 17n per se, or maybe instead of n cubed over here we'll just have 7. So this over here, and all of this is to the power of n, this in fact becomes very simple, since by the root test our limit as n approaches infinity will just be of this function. And you see the power is the same, so by the limit rules you have 3 over 4. Basically it's equal to 3 over 4, and it's less than 1, so we know it converges. If we try to do this by any other test, like the comparison test or the ratio test, it would be very, very difficult to evaluate it. So that's about it for the root test, end this video. Thank you so much for watching. See you in the next one, and bye-bye.